Hello everyone. Let's see our next tutorial, that is simulation model. So up till now we have created a tag CAD model and we have created an abstract model file. Now we will see how to link these two things and create simulation model out of that. So let's see what exactly simulation model is. You can see on screen I have opened the abstract model file, and now we want to link our CAD model with this abstract model file. So for that, one can click on this icon, that is simulation model, or there is one more way, that is one can click on this action, create, and simulation model. So after that, it will ask me for the CAD model which is to be linked. So I'll just select the coupling FEA assembly and I'll click on open. Now the simulation model is getting ready. That is your CAD model and abstract model file. Those are getting linked with each other. So this is the simulation model created for coupling FEA assembly. In simulation model, you can see there are three tabs given here. One is class, one is component, one is model. So under class, there would be simulation classes. Under component, there would be corresponding simulation components, and in model tab there would be corresponding geometrical entities like volume, surfaces, edges, vertices. So this is all about these three tabs. Now under class tab you can see the classes, and if I click on any class, then it will highlight the respective geometrical entity in the graphical user interface. So in CAD model we have done the tagging, and based on that the corresponding geometrical entity will be highlighted here in the simulation model. For example, if I'm clicking on this steel 2340, then the part on which we assigned steel 2340 tag in my CAD model, those will be highlighted here in the simulation model. Same would be the case for relations also. So if I'm clicking on any relation, then the corresponding geometrical entities will get highlighted. Same applies to your attributes. So if I'm clicking on any attribute, then the geometrical entities on which that attribute will get transferred, that will be shown here in this graphical user interface. So this way one can verify their classes, relation, their attributes, if they are representing correct geometrical entities or not. Now the model which you are seeing on the screen, we call this model as a non-manifold model. So now what exactly the non-manifold model is? Now let's say we'll focus on two parts, that is this link structure or the pin structure and this hub structure. So in original CAD model, there are two surfaces at the interface of these two parts. So one surface belonging to hub structure, one surface belonging to your pin structure. But in non-manifold model, there would be only one surface at the interface of these two parts. So we'll see here, I'll just hide this outer surface. Now this is the surface which is the common surface between these two parts. So if I hide this surface, you can see there's nothing else in between these two parts. But in original CAD model, there would be two surfaces, one belonging to one part and another belonging to your another part. So when two parts are in touch with each other, then in your original CAD model, there would be two surfaces at that location, whereas in the non-manifold model, there would be only one surface which will be belonging to both the parts. So that is the difference between your non-manifold model and your original CAD model. Now, if I click on any class here, for example, pin contact, then respective geometrical entity will get highlighted in the simulation model. Now, every class or every relation has their child entities, for example boundary. So the boundary will represent the boundary of that class, that is which is touching with the air, which is not in contact with other classes. Again, boundary will have their subchilds like inside, it means the inside of that boundary, outside is the outside of that boundary. Now there are some pruned entities, we'll talk about the pruned entities later. Again, interface is one child entity of this class. So interface means the common entities with other classes. So if I make it transparent, then you can see at these three locations, the pin contact class is touching with the other classes. So it's highlighting the three locations. Similarly, pruned entities. So pruned 3D means it will highlight only 3D. It will not have the 2D, 1D, 0D entities. That is, it will not have the surfaces, edges and vertices. Pruned 2D means only 2D. That is, it will have only faces. It will not have the edges and the vertices. Pruned 1D means only 1D, that is the edges. It will not have the 0D entity, that is vertices. And pruned 0D means only vertices. So to view the vertices, one need to go in the view, show and point vertices. So you can see the vertices highlighted by yellow color are belonging to this pruned 0D entity of pin contact. So every class and every relation will have such kind of child entities, and you can use those child entities based on your requirement. Now let's see what is the difference between unpruned and pruned entity. So I'll just select this relation, that is relation between steel 1430 and steel 2340. So it is highlighting the common entities between these two classes. I'll just make it transparent here. So when I'm saying unpruned 2D, then you can see it is highlighting faces, edges as well as vertices. But when I click on prune 2D, then it will only consider the 2D, that is, it will consider the faces. It will not consider the edges, it will not consider vertices. Similarly, if I click on unpruned 1D, then it will consider 1D as well as 0D, that is edges and vertices. But when I'm clicking on pruned 1D, that is only 1D, then it will just consider the edges. It will not consider the vertices. So unpruned means it include that dimension as well as their lower dimensions as well. But when I'm saying only pruned, then it will only include that dimensional entity, not the lower dimensional entity. Let's now see how the attribute gets transferred from class to component tab and component to model tab. So let's first see my steel 1430 attribute. So when I'm clicking on that, then it is highlighting the respective geometrical entities. Now you can see here it has highlighted region, faces, edges and vertices. So it has highlighted everything from this geometrical entity. Now let's take one example of attribute, that is solid element set attribute. So you can see here I have specified it on pruned 3D of steel 1430. So when I click on this attribute, a respective geometrical entity will get highlighted. So you can notice I have given this attribute on pruned 3D of steel 1430, that is only 3D entity of steel 1430. That's why you can see only region or the only 3D entity is highlighted here, not edges, not vertices or not faces. Now let's see what happens to this attribute when I go from class tab to component tab and from component to model tab. Before that, please make note that the attribute name is steel1, and you can open this attribute by double clicking here so that you can see the details whatever specified in this attribute. So model association is the entity on which you have specified this attribute. So let's see what happens to this till one attribute when we go in the component tab. Just note that still1430 is the class which you have assigned on the three parts, that is left hub, right hub and this pin structure. So when I go in this component tab, you can see this solid elements as attribute with naming still1. You can find three attributes here now. So one belonging to pin, one belonging to left hub and one belonging to right hub. It means when attribute is transferring from class tab to component tab, it is getting splitted based on your simulation component. So in this case, still 1430 was assigned to these three parts, and that's why it is splitted into three attributes in the component tab. Similarly, if I go in the model tab and if I see the attribute, again you can see the three attributes here because it is now transferred onto the region, that is the geometrical entity. So each region belonging to each component. So this way every attribute will get transferred from class tab to component tab to model tab, and you can verify if your attributes they are transferring correctly at the required geometrical entities or not based on your requirement. Let's see some more details about this simulation model. So there is a preview mode available by which you can see where exactly your load, your constraint or your contacts are present. So for that one need to go here in the view, preview and on. So this way a preview mode will get on and you can see this arrow indicates your loading location. This triangle represents your constraint location and the contacts for that I'll just make it transparent, and you can see this pink arrows will represent the contact location. So this way preview mode will help you to identify where exactly your load, your constraint, your contacts are present. Now, in your practical model, there might be a lot of locations where loading would be there, a lot of locations where constraint would be there, a lot of locations where contact would be there. Then, in that case, you can just verify which attribute is corresponding to which location. For example, here, if I click on this point force attribute, then the arrow will be highlighted by yellow. So this attribute is corresponding to this arrow. Similarly, if I am clicking on the constraint attribute, then you can see this triangle is getting highlighted with yellow. It means this attribute is corresponding to this triangle annotation. If I click on this contact pair attribute, then you can see it will highlight in yellow the contacting location. Now, if you are more interested in knowing which one is my master, which one is my slave, then you can go in the model tab. You have to just open the attribute there, and there's an option called as show contact list. Click on that and it will show you master and slave entities. So right click on that and just click on show master. So with yellow arrow you can see the arrow indicates your master entities, that is it is pointing from your pin structure to your hub structure. Similarly, if I click on show slave, you can notice the arrow corresponding to yellow color are my slave entities. That is, slave entities are pointing from my hub structure to my pin structure. So this way you can see more details about the contact, master and slave entities. There are some options available like action and view. So under view You can show or hide some of the geometrical entities based on your requirement. So for example, if I want to see the vertices, I'll just click on these point vertices and the vertices will get displayed on the screen. I can off it just by again clicking on the point vertices and it will get off. So this way you can use this hide and show option. Similarly, under action, you can go in the get info tab, model validity and with geometry. So this will show you whether your model or the non-manifold model is valid or not. You can go with the or you can proceed for the meshing or not. If it is not valid, then it will highlight some geometrical entities which may be having some problem. So you can just modify or update the CAD accordingly based on those geometrical entities. Also under get info, you can get the information about non-manifold model. So if I click on this, you will get some information about the non-manifold model like how many region, faces, edges or vertices. So it includes. Likewise, there are options available. For example, I can find the shortest entity also from this model. So if I click on this, it will give me the length of the shortest entity. So these are some of the options available under get info. Under select, you can select maybe a particular vertices, edges, faces or region with their IDs. For example, if I'm clicking on edges and if I type here 53, then edge which is having ID as 53 will get highlighted here. So this way under action select, you can select some geometrical entities. So there are some options available in these two tabs, that is action and view, and you can use it as per your requirement. Let's now proceed for the meshing. Now for meshing, one need to click on this icon. Again, there is one more option under action. You can go in create and mesh model. If you click on this, automatic meshing will start, and the meshing it depends on the mesh attribute which you have specified. So you can see here the meshing is completed based on the attribute which you have given. Now one can see some more details about this mesh under mesh statistics. So one need to go in the view mesh statistics. You can get information about volume mesh or the surface mesh. So I'll just click here on the volume mesh. Again, I can select the criteria which I want. So I'll just select aspect ratio here and I'll just click on OK. So you can see here now it has shown me details about the aspect ratio. So for example, this is what my maximum aspect ratio is for this element 267, and this is my minimum aspect ratio for this element. Again, the more details about the aspect ratio, that is how many elements are falling in the aspect ratio range. So likewise you can get the details about any of the criteria. Now I can see where exactly this element is, so I'll just close this one and I'll go in the action, open region selector. So I can select here ID. So my ID was 267. I'll keep minimum maximum as 267 and I'll click on update. So you can see here on my screen the element is highlighted. So this element is having that maximum aspect ratio. Similarly, you can set any other criteria, maybe aspect ratio, minimum 1, maximum 10, and I'll click on update. So the elements which fall in this criteria will get highlighted on screen. So likewise, you can find more details about the mesh under mesh statistics. Now you can see a sectional view also. For that, one need to go in the action, open, click plane editor. Now you can just select any axis based on your requirement. I'll just select Z. I'll click on new, and then one can move this arrow based on the requirement. Then I'll just select view, hide all but selected. So this way I can see this sectional view of my mesh. So that's all about this meshing. Now we will see how to do the export. Now I'll just on all the elements. So I'll go in view, show all. I'll just delete my clipping plane. So I'll go in action, open clip plane editor. So this is the plane which I had created. I'll just delete it and I'll just exit it. Now we'll see how to do the export. For that, we need to click on this icon. Again, there is one more way, that is action, export, and this optistr. So once I click on this, it will ask me for the folder name. So I'll just create one folder like export coupling model, and I'll just select that folder. So my file will get exported at that location. So if I go there in that folder, so you can see my OptiSert file is written here. So I can just open it, and we can see it includes all the data which is required for the solver. So some information related to subcases, grid ID is there, maybe element data, C tetra element data is there, and towards the end the force and the loading details. So this is how you can create the simulation model, and you can do meshing, and you can export your solver input deck. So that's all from this tutorial. I thank everyone, and if you have any question or any queries, then please feel free to contact at support@novusnexus.com, and we'll get back to you accordingly. Now in next tutorial, we'll see how to avoid a conflicting situation in CAENexus. Till then, have a good day. Bye.